everybody can do this. I want now we're going to multiply and we're going to add and we're going to subtract. So pick a number that's easy to start working with, okay? Somewhere between 1 and 10. Everybody pick a number, but don't tell me. Think of a number between 1 and 10. And once you have a number, raise your hand so I know that everybody's ready for the next step. Quincy, there we go. All right. Oh, I see a thumbs up. All right. Now, this number you're thinking of, we're going to call it your key number. So if I say your key number, the number you just picked is the number you're going to use. Does that make sense?
Okay.
Okay. Let's see. Multiply your key number by 2. And when you have an answer, raise your hand so I can see who's ready to move on. All right. There we go. Thumbs up again. Let's see. Multiply by 2. Add 4. And let me know when you've done that. All right. And now divide by 2. Let me know when you've done that. All right. Now subtract your key number. Has everybody done that? Now subtract 1. Has everybody done that? Now, if you did your math right, and if I told you how to do the sequence correctly, everybody should have the number 1 for an answer. Does everybody have number 1?
Yes.
You guys are great at math. Very good. That's a simple magic trick, and it's all about, believe it or not, algebra. And I know you guys haven't done algebra yet, but that's an easy magic trick. Let's see, let's try another easy magic trick. And we'll start the real show in a second. As soon as Quincy tells me we're ready to start, we'll start the real show. Let's see. Or a lie.
Oh, we can start right after this.
Yeah.
Right after. One more. Or a lie.
Yeah.
Do not tell me. Think of a number between 1 and 10. Raise your hand when you have one. Was it 7?
Yes.
All right. Another easy magic trick. All right, so we're ready to start the real program. Well, my name is Ed the Wizard, and today's program is called Ed the Wizard's Alchemy Laboratory. And like I said a moment ago, everything we're going to do is in here. But not everything in here we're going to have time for today. And alchemy, does anybody know what alchemy was? Any guesses? Or a lie?
Kind of like chemistry.
Kind of like chemistry. Does anybody know the most famous alchemy experiment that they were trying to do? They were trying to turn lead into gold. Has anybody ever heard of that? All right, trying to turn lead into gold. So that's an old alchemy experiment because lead was plentiful. Gold was scarce. Lead and gold are both heavy. They're both malleable, which means they bend easy, they melt easy. So why can't we turn lead into gold and make it valuable? Because they're both what we call a base metal. And what we now know is you can't make a base metal. We can make an alloy by blending like tin and lead, and then we get pewter. But we can't make tin or lead. A bronze metal is, I shouldn't have said that, copper and tin, I believe, makes bronze. I might be wrong on that. But either way, we can make bronze, but we can't make copper or tin. So, well, we are going to do some experiments using 3 out of the 4 Greek classical elements. Does anybody know what those elements were? Can somebody name one element? Or a lie?
Gold. Hold on. Wait, no, arsenic was in. Phosphorus.
No, well, today I'm talking about the 4 original Greek elements. I'll give you a clue. See the dragon? What's the dragon breathing? What's he breathing right here? Fire, right?
Oxygen. Colvin.
Or air. Yeah. So there's fire, air. What's that?
Colvin.
Colvin?
Oh, the full class. Oh, those. I assume.
I'll give you another clue. What's in this bottle?
Water, right? Water.
Water. So we have water, air, fire, and there's one more.
Oxygen.
Well, oxygen I'll call as air. And we stand on it when we go outside. What do we stand on when we go outside? The ground or earth. So we're going to work with water, air, and earth today. So let's start off using some water. Water covers 71% of the Earth's surface. Did you know that? 71% of the Earth is covered in water. And 97% of all that water is salt water. That means 3% of all the water in the world is fresh water. And of all that, 77% is frozen. That means 1/2 of 1% of all the water in the world has to be shared by every human, animal, plant, because that's all we have for fresh water. Less than 1/2 of 1% of all the water is fresh water. So we're going to use some gilly water right here and a measuring cup, because alchemy, they started to make measurements and they kept careful records. So if something worked, they could repeat it. If something didn't work, they didn't want to waste their time and repeat a bad experiment. And I have a cauldron and 1 ounce of water. I'm going to pour the water into the cauldron. Now, in Harry Potter, when Professor McGonagall was trying to teach Transfiguration class, do you know the spell that she taught Ron when he turned his rat scabbers into a goblet? Does anybody remember the spell? It was Verta Virto. And that's actually Latin. Virto means to turn around, to change, to make different. And vera means the truth. We're going to change the spell to Virto Glicine. Is everybody ready? On the count of 3, can you say that with me? 1, 2, 3. Virto Glicine.
Verto Glicine.
And let's see what we have done. We have changed water from a liquid into water, a solid. Because water can be found in 3 states, and I don't mean Massachusetts, Vermont, and New Hampshire, but as a liquid, as a solid, and as a gas or a vapor. So we're going to do the experiment one more time. We'll pour in 1 ounce of water. We'll pour it into the cauldron. And this time we're going to say Virto Nebulae. Is everybody ready? On the count of 3. 1, 2, 3.
Verto Nebulae.
Good. And what do you think nebulae means? Lorelei?
Since you did a solid, you did a liquid, I'm guessing that you're going to turn it into gas.
A gas. For example, have you heard of cumulus nebulus, a cloud? Well, nebulae means gas, fog, vapor. So we have now turned water into a solid and into a gas. So before I teach you how to do this, any ideas how I did it? Anybody want to take a guess? Lorelei?
Maybe you put for the dry, for the ice thing, maybe you put something, maybe like something that freezes stuff, maybe like dry ice in it. So then you put it into it froze, then you dumped it back out again.
You're on a pretty close track. Not quite, but pretty close. Anybody else? Emily, or is that Abby? Who's raising their hand? Emily or Abby? Abby? All right, what do you think, Abby? Or you, right there.
Do you want to speak up? We can't hear you that well.
That you use probably matters. Like maybe there's the combination of the ingredients does something.
The combination of the ingredients. What kind of ingredients?
I don't know.
All right, let's see. Any last guesses before I show you? Let's see. Sangeetha, is that how you say it, Jenny?
Yeah. Actually, my name is Vihan.
Yehan?
Vihan.
Okay, Vihan. What's your thoughts?
I think you put a sponge in the cauldron, and then you poured the water, and then the water just got inside the sponge, and then you already previously put ice cubes in it, and when you put it out, the ice cubes came out, but the water didn't.
Very, very good. That's exactly what I did. Inside the cauldron, I have a sponge. However, the sponge is only going to hold so much water, and I want to do it twice. So what do I need besides one sponge? I need another sponge. It will hold more than 2 ounces of water. So to do this at home, get yourself a coffee cup, because it has straight sides and a flat bottom. Get a brand new sponge, trace it around the coffee cup, and then you'll notice that the sponge and the coffee cup. That's so that when you push it in, it doesn't want to fall out. Now this sponge is a little bit too big for this coffee cup. I made it for the cauldron, and then you just push it to the bottom, just like that. Put your ice cube in, and now you're ready to turn water liquid into water solid. And if you want to do it twice, put in 2 sponges, and then you can go from a liquid to a gas. Now, let me give you a couple pointers on that. Why do we say this? Why do we say Wellesley and Virtual Nebulae? Lorelai?
Do they have any connection? Are they like Latin names or something?
I'm sorry, say that again, please.
Are they like Latin names or something?
Latin names, but why do I say that? Why do I say the spell?
To give it a little, like, to make it like more mysterious
More mysterious?
in a way, and it gives you a sense that you don't have a sponge inside. You're actually saying something.
Makes it sound more magical. But what I'm really doing is I'm giving the sponge a little bit of time to soak up the water. You pour the water in and immediately try to dump the ice out, the water's going to come out too. So I say the spell so that the sponge has time to soak up the water. And you want to put the ice cube in about 5 minutes before you do the magic trick. You know why? Because an ice cube right out of the freezer, as it starts to melt, it's going to freeze and stick to the sponge. So put it in there a few minutes early so it has a chance to melt a little bit, and then it won't stick to the sponge. So now you know how to turn water into a solid and water into a gas. And you don't have to use a volunteer, and you don't have to use a measuring cup. You can just get a cup with some water in it and just pour some in. Doesn't matter how much, as long as it's not too much. You can just pour some in, you don't have to measure.